One of the biggest advantages to the SAT is that you can use the TI-89, and there will likely be systems of equations problems that you solve in the calculator section. Okay, there's also likely ones that you solve in the no calculator portion, but there will very likely be one that you solve in the calculator portion. Okay, so what I want to do is I want to walk through this first problem right here and how you can use your TI-89s to solve it. The TI-89 actually has a systems of equations solver template built into it. Okay, so if you take out your calculator, we'll go ahead and take a look at this. All right, so along the top, the normal tabs, F2 should say algebra. So it's the F2 algebra tab. We want to get to the custom tabs. So to access the custom tabs, you can see this little custom menu in blue here. Hit second home, and notice your tabs change. Okay, and now the third one, F3, says solve. If you click on it, that's your system solving template. Just scroll down to number 4 and hit enter. And then what you can do is just scroll through. Okay, and right after the parentheses, if you type in your first equation here, so 2x minus y equals is right below the x, 6, scroll over to right before the comma and type in your second equation, x plus 2y equals -2. Make sure you use the change of sign key for the -2 and not the subtraction key. And if you use that template, everything else is already set to where it's written in the correct order. So just hit enter and it'll give you your solution. So you see that your answer here is going to be 2, -2, which gives us answer choice C. Yep. Okay, so I'm going to go through it one more time. All right, so normally your tabs are going to look like this. Okay, so when you look across the top, you see that the F2 algebra tab, there is no solve tab. So if I hit second home, it changes these to custom tabs. And in the custom tabs, the option F3 says solve. So we're going to select that. And you're going to choose the very bottom one. It has the template already kind of built in. And now, if your cursor looks like this, so see how this is that? This is an overwrite cursor, the big block cursor. You're not going to be able to do this. So if that's how your cursor looks, if you hit second and then backspace, that toggles back and forth between the block cursor, the overwrite, and the insert cursor, the little thin cursor here. So if we scroll this cursor right after the parentheses, and we just type the equations directly in. So 2x minus y equals 6. Scroll over. Now let's say you accidentally deleted a space. If you need to recreate the space is this alpha key, this white key, and then this change of sign. You see this little, what looks like an underscore a little bit, like a bracket laying on its back. What you're going to do, they're right to the classroom, right just below us. If you hit alpha and then this button, it creates the space, and then you can write your second equation, x plus 2y equals -2. Again, the change of sign key. If you've done it right, just hit enter and it will solve that for you. And now, if you do this and the answer says false, that means there's no solution, which means they're parallel lines. And if you get an answer that has an @ symbol with any other number after it, it's just labeled like x1, x2, x3, x4, but if it says like @1, @2, @3, if you see that, then what it means is that you have an equation that is like the same. They are the exact same answers. Okay, so the two equations give you an infinite number of solutions. Right. So the next question then on that same page, I want you to do the very next one. Okay, question 14. When you see one that asks you for something that's not just asking you for the x coordinate by itself, the y coordinate by itself, or the ordered pair. Okay, if you see one that's asking you to find some expression, more than likely that expression can be created through some kind of a unique but direct combination of the system or the equations they gave you. So gentlemen, they moved it to, it's in the class, Mr. Hahn's classroom right below this one. All right, so when you look at this, what can you do directly with these two equations to get 3x plus y? And it's usually really simple. It's usually adding, subtracting. So if you just add straight down these columns, right? What do you get for your x's? 3x. What do you get for your y's? Plus y. And what do you get for your constants? 15. So what you see is that 3x plus y has that value of 15. Okay, this was the type of question that they used to have on the SAT all the time. Okay, they just started bringing these back in the last year. Okay, they hadn't had them from 2016 until, it really was just about a year ago that they started bringing these types back. So if you're being asked to find a value that's some expression itself from a systems of equation, you're more than likely just going to directly add it, directly subtract it, or some kind of a unique combination of those. All right, go ahead and try the next question. This is one that, again, you can, if you want, use your TI-89. This is in the calculator section, and it's not a bad idea because, as I mentioned, if you get an actual value for x and y on this, then you would have one solution. If you get a false as your answer, you'll have no solutions. And if you get an @ symbol in your answer, as acting as a variable, you'll get infinitely many solutions. And so as you're finishing yours up, I'm going to go ahead and go into my custom tabs, which I already have. F3, choose my system solving template. And I'm going to scroll in front of the and, type my first equation. 5x minus y equals 9. Scroll after my and, type my second equation. Negative 60x plus 12y equals negative 108. Again, make sure you use the change of sign key and not the subtraction key. And so do you see how mine says, like, one variable is represented by the @ symbol and then some number? Okay, more than likely, yours is going to be 1 as well. It goes in sequential order. So if I were to do this another time, my next variable would be @2 and then @3 and so on. Okay, so if you see that @ symbol, it means that there's an infinite. These two equations are the exact same thing. Okay, and so it's just no matter what, or whatever you plug in for x, the y is going to be based on that. But it's going to have an infinite number of solutions for that. All right, so for this one here, it's infinite number of solutions. All right, questions on any of those? All right, so let's take a look at a hard question. This is in this calculator section, so I want you to try question 17. This is on page 7. This fits that model of what I just mentioned. You're not solving for x and y here. You're solving for some unique expression. And so what we want to do is, let's take each of these individually. Okay? Can we find this piece, and then can we find this piece? Well, the easiest thing to do is if we just combine straight down these columns. This second binomial here is the exact same. We're subtracting it from the previous. So if we add these two together, what we can see is we have these two 1/3 t plus 5s. I don't have to physically add them together. When I add two of the same thing, it's just like saying 2 times that is equal to, and if I add down my column over on this other side, I have a total of 56. And so now if I divide both sides here by 2, I get that 1/3 of t plus 5, this measure, this first binomial, is equal to half of 56, and so that's going to be 28. I can replace that with a 28. I can then do another combination to get my 1/2 t to the minus 4s. So if I do that, what I can do is I can change the sign of this term right here. I can subtract everything in this equation by a negative. So I'm going to write it above. So that gives me a negative 1/3 t plus 5. Minus a minus gives me a plus. 1/2 t minus 4, and it gives me a negative 19. So now if I combine these two values, these two equations here and here, just directly combine straight down the column, my first binomials cancel. I get 2 of these 1/2 t minus 4s, and that's equal to 37 plus a negative 19. If I combine those, I get 18. And so now if I divide both sides by 2, I get my second binomial here. 1/2 of t minus 4 is equal to half of 18, or 9. So here is my answer. If I multiply 28 times 9, I get my solution, which is going to be 252. Okay, so this would be a much later problem. This is a question that most students are not going to get right, okay, but it is one that you can solve. Okay. But that's sort of the direct combination type of process that they're looking for. All right. Let's go to the next odd question here on page 8. Okay, you're still in the calculator section, so you can use a calculator if you want. But now the idea here is when you read that all the answer choices are numbers, which again, my first strategy, always scan your answer choices. Okay, when you see that they're all numbers, that tells you that one of those is the answer. Okay, and so you don't always have to solve things mathematically. Now, we are going to go through in a second how to solve this mathematically. Okay, but probably the quicker way to approach this is if you know that Angelica is going to, A is going to equal one of these 4 answers. We know that. We also know that Raul, is not 11 more than this. So if we add 11 to this, we get our R values. So what I can do is I can just quickly go through and say, well, if she worked 24, 11 more than that is 35. 11 more than 35 is 46. 11 more than 37 is 48. 11 more than 48 is 59. So now those are the options for him. And what do you know the sum of theirs is? So here, if I take each of those, I know that it has to equal 59. So all I have to do to solve this is find out which of the A values falls in the row that adds up to 59. And what I can see is this is the only one that adds to 59. So my answer is going to be 24. So that is the easiest way to approach this. Okay? If you understand that the answer choices contain the answer, you can just test and plug in the possible solutions. Now, mathematically, what they're really trying to ask you to do here is to write up a system for this. Okay? So there's 2 relationships that you know. You know that R worked 11 more than A. So R is equal to 11 plus A. And you know that they worked a combined 59. So R plus A is equal to 59. So you actually can create this systems of equation, right, where R and A could be X and Y if you wanted to type them in. Although this is one that's pretty easy to use, just substitution, right? Since R is equal to A plus 1, what we can do is we can replace, or A plus 11, we can replace R with A plus 11, plus A is equal to 59, and we can solve this. 2A plus 11 equals 59, subtract 11. 2A is equal to 48, divide by 2. A is equal to 24, confirming our answer that we got by just plugging in the numbers from the answer choices. All right. Questions on that? All right. Let's look at the next one, because this is more typical of the basic questions. Okay? And I'm not going to go through it too much. I'm just going to start talking about it, but I want you to see if you can answer this. You should be able to do it very quickly, despite the fact that there's lots to read. Skim the answer choices. You notice they're all linear forms. Linear forms are initial values and rates of change or slope, right? Constants and slopes. So you can see what are your initial values in front, and then what is your adjustment? What rate of change is happening in this scenario? So all you have to do is skim through and see. It says one of the requirements is 222 words per minute. Donald can currently type at 184. So notice the 222 was just a distractor. Okay? You're starting with, or your initial one is 184. so I can eliminate those two. And then he believes with practice he can increase his typing speed. Increase means plus, so right away I know this is my answer. If you want to go in and check it, you can. But which of these moments would model that 8 months from now, or m months from now, what that change would be? Okay, and it's your starting point, 184, plus your rate of change, 8. The 8 words per minute each month, and that is going to give you your model. All right, so let's go back here to another challenging question. Okay, so I want you to see if you can solve this problem here. Again, it is a linear model. The highest power, or the power of t, your variable, is 1. Okay, but see if you can identify what the pieces of information or how they can be used to solve this problem. One of the most helpful things that you can do in prepping for the SAT, especially in the math section, but also for the verbal stuff, is to do problems. Okay? I mean, a few of you had me in class, and it's all about doing problems, redoing problems until you kind of get how it works. And the same is true for the SAT. Okay, so when you look at a problem like this, if you were just spending a few minutes to do it and you look at a problem like this, it's possible you check out and just say, nah, I'll figure it out because it looks more complicated than some of the other ones. Okay, but look it over. If you can identify what is the fastest way you can solve these questions, and then that's what you can carry over as a strategy into actually taking the SAT. And sometimes it doesn't even mean you have to find the answer. Sometimes you just have to eliminate at least one answer. Okay? So think about if you randomly choose, you have a 25% chance of guessing right. Okay? But if you can eliminate one choice, okay, now you have a 33% chance of guessing right. If you can eliminate two choices, you have a 50% chance of guessing right. So the idea is that not only do you need to try to solve it, but you can also just try to eliminate other answers. Okay, so if I'm looking at this right here, what I see is I have two pieces of information in this problem. So again, I first scan my answer choices. It's a linear form. Okay? So when I go up here to see, I have a gap related to a temperature. Well, I see that the width, W, is a function of temperature. So my temperature is my input, my x coordinate. So I know when my input is 40, my output's going to be 2.875. And for my second point, I see when my input is 100 degrees, then my output, the gap, is 1.875. And so I have these two sort of data points here to go by. Okay, so the first thing is that I would look at in this is, let's say I don't know, I can't really figure out how this could be solved. But if I know that these are solution points, what I can do is I can look to see if I plug a 40 in to my t value, then the answer should be 2.875. Would it be in this first equation? 40 minus 40 is 0, so that's going to cancel all this first part, plus 2.875. Yeah, so I can't eliminate that one. But what if I look at this second example? If I plug a 40 in here, 40 plus 40 is 80. 80 times the negative 1 over 60 minus 2.875, is that equal to 2.875? No. So I can eliminate that as my answer choice. Okay. If I plug in here, 40 minus 40 gives me 0, times 60 is 0, plus 2.875. Yes, that's a possibility. And then here, same thing, right? 40 plus 40 times 60 minus 2.875 is a much larger number. So right now, I've now increased my chances of guessing right to be 50%. Okay, and so your only other thing that you need to do is if you just test the other set of points. So here, if I take 100 minus 40, which is 60, negative 1 over 60 times 60 is negative 1. Okay, negative 1 plus 2.875 is 1.875, so that one checks. And when I test that here, 100 minus 40 is 60. 60 times 60 is an extremely large number. Plus 2.875 does not equal this number. So just by process of elimination, I just tested those two ordered pair that I created from the data given, and I see that my only answer could be option A. Okay, so again, this is another argument against the SAT. You can get the right answer without knowing how to solve it, just because you know how to eliminate choices that don't work. Now, if you were going to solve this, what you could do is you could find the slope between these 2 points here, right? So if you took the difference of their outputs, so 2.875 minus 1.875, divided by the difference of their corresponding inputs, so here it's a 40 minus a 100, what you're going to do is you're going to get this negative 1 over 60. So you know your slope is negative 1 over 60, so it has to be A or B. And then it's the same idea, right? You can go in and you can plug these points in. But this was not even necessary, because just by plugging in the points, we were able to eliminate the problems that were not correct. All right. So let's jump to this next type of problem on page 9. And we're going to talk through a few of these, because over the last maybe 3 or 4 SATs that have been released or that are on that mega thread, this shows up an awful lot. It shows up in almost every one. And once again, it didn't used to show up there. It just started showing up in the last year or 2. And so what I want you to do is to take a look at some of the types of questions involving interpreting scatter plots of linear linear equations. Okay, so try the first one here. See if you can identify which of these would be a likely equation of best fit. Okay, and then question 24 is the one I was mentioning that is showing up a lot. So we'll do that even number as well. What makes this question challenging is it's not your typical look at the y-intercept, right? Because you don't see, it doesn't start at 0, 0. You don't see the origin of this graph. You see where the x-coordinate of 5 and the y-coordinate of 90 intersect. So it's going to be really hard to try to figure out what's the relationship between this graph. Now, you might be able to get a sense of it, but again, here, if you were to just sort of sketch a line of best fit, it just gives you an estimate. And so the suggestion for something like this is find a point that is close to or lies pretty close to this line of best fit, but also has coordinates that you know, that you can find. Well, if I look at this point right here, I see it has a x-coordinate of 6 and a y-coordinate just above 110, right? So somewhere around 112, let's say. It doesn't have to be exact, but it's somewhere around that. And it falls on this line of best fit, or it's an approximate fit to this line. You could have done the same thing right here, 6.6. You could have done some others, but the reason I chose this one is 6 is just an easier number to plug in, right? It's not a decimal value. So I'm going to plug in 6 for each of these equations here, evaluate what I get. So if I took negative 5.2 plus 1.6 times 6, is that going to be somewhere close to 112? I don't need a calculator to tell me that's not going to happen, right? Right? 6 times 1.6 is nowhere near that. So that tells me I can eliminate this. Same idea here, right? 15.2 plus 1.6 times 6. There's no way it gets anywhere close to 112. I can eliminate that. So now I'm looking at negative 15.2 plus 16 times 6. Well, if I take 16 times 6, I get 6 times 10 is 60, 6 times 3 is 36, 60 plus 36 is 96. So basically it's saying, am I looking at negative 52 plus 96, or am I looking at positive 15.2 plus 96? Which one is going to get me to 112? Not this one, but this one will, right? 96 plus 115 is approximately 112. So just by picking that point that falls on the line of best fit and evaluating it, again, there's a reason why that middle point or that point that falls on it is an integer. It's easy to test, okay? And that is the design of the test, the SAT itself. All right, so this is the question I started to talk about. I jumped the gun a little bit, but this type of question here has started showing up on the SAT. So again, my guess is going to be that you will see a question like this. Okay, so I want you to answer it, and then I'm going to talk about, there's two ways that they'll sort of ask this type of question, okay, and I'll go through each one of them. Or actually, there's another one I think that shows up a little bit later. Okay, but these questions are going to be designed in such a way that they really just want you to identify whether points fall above the line of best fit or below the line of best fit. But the way that they ask it can be confusing because sometimes it is like how many of these are above the expected values. If that's the case, you're looking for points above. And then some of them say, how many of these have a line of best fit that's above the point? So do you see how they use above in both of them, but in one case they're looking for the points above the line, and in the other case they word it so you're looking for the line above the points. So just read the question really carefully. So here it says, what's the number of computers for which the line of best fit predicts a value that is less than the actual value? So is this going to be a line above? Is the line above the points or a line below the points? This is a best fit predicts a value that is less than the actual value. So will the line be above the points or below it? The line is below the points, right? And so when we're counting these points, what's the number of computers or how many points? We want to find the points that fall above the line. Okay, so for the points for which the line is below the points, and if I start counting, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a total of 9 points that fall above the line, or again, it's 9 points for which the line is below those points. Okay? And so it really comes down to how it's worded. So once again, read it carefully and then identify. Do you want the points above the line or below the line? Do you want the line that's above, or do you want the line to be drawn above the points or below the points? Okay? And so this gives us an answer of 9. All right, so that is the summary. Those are the most common algebra concepts. Okay? So they call them heart of algebra. Those are just Algebra 1 concepts covered on the SAT. Okay? The next highest number of, or the next highest number or percentage of questions come from Algebra 2. Which is called Passport to Advanced Math. These are just nonlinear equations. Okay? And so I want you to go ahead and we'll start with question 1 here. Okay, so see if you can answer this. This is on page 10. Right, so exponential functions are either going to be, or will tend to be, growth or decay. Okay, and what makes the difference between those is you have some initial amount, A, with some number 1 plus a rate, a decimal rate, and this rate is the percent change that happens taken to the power of t. Okay, so if it's a decay, what happens is that 1%, or that 1, which represents 100%, plus or minus the percent, the decimal percentage. So here, if you subtract your percentage rate as a decimal from 1, then you're dealing with decay. Okay, so if the base of our power is greater than 1, it's growth. If the base of our power is less than 1, it's decay. So here, when you see that this radioactive substance is decaying, that means right away that you know that the number inside your power here has to be less than 1. So those are the only two possibilities here. Okay, so 388 can't be the number that's the base of our exponent. That's a value that's much greater than 1. Okay, so what we're seeing here is if it's decreasing at a rate of 13%, that means that we're going to use this form. So it's A, the initial amount, which is 388, 1 minus the 13%, but it's as a decimal. So 0.13 to the power of t. And so this gives you the form that you're looking for, which would give you answer choice D. All right. try the very next question. When you look at this power in your exponential growth or decay form, and that number represents the number of years it takes for that change to happen. And so if we go up to here, this means that there's a decrease of 13% for every t years. And so if it happens to be a fraction, what the fraction means is that if you're looking at a fraction of 1 over 3, what that's saying is every 3 years, okay, that change of 1.005 happens. Okay? And so the 1/3 means that it's, when you look at that, it means 3 years, whatever the denominator is, to get the growth that happens right there. So when you look at this here, and you want to see what's the value of n, okay? So how many years is it going to take for that growth of 0.5%? Since the denominator is 1 over, or the power is 1 over 3, it's going to take 3 years to get that growth. Okay? So you might think right there that the answer then is 3, because it is 3 years. But what is the value? Now, so something like this would be kind of much later in a section than what you might think. Okay? So you might look at that and think, well, why would this be so late in a section? It's clear the answer is 3. Okay? But it's at the end of a section or later in a section for a reason, because they're asking you to find the number where n is the number of months. So if that change happens in 3 years, how many months is that going to be? 3 times 12, which is going to be 36. So sometimes there's a reason that an answer or a question that seems like it's too easy to be at the end of a section. If that's the case, just be very wary of it. Okay? Why is it that this is later in the section? And it's likely there's some kind of like a trick to it. Okay? All right. So let's take a look again at how that sort of fraction form plays out in this. Okay? So if you look at this question right here, and I'm just going to talk through this, and then I'm going to have you do the next one on your own real quick. Okay, but if you talk through this question, when you scan your answer choices, what you can see is you're dealing with the fact that the 1 over 2, the base of your power is less than 1, so you're dealing with an exponential decay, half-lives, right? And you look to see, if you look in the denominator of those powers, that tells you how many years it's going to take for that one change to happen. So the amount cuts in half when you look at this every 200 years. Here it cuts in half every 200th of a year. So it cuts in half 200 times per year. This one is 150 times per year. And this one, it cuts in half every 150 years. So when you're looking at this where it says the half-life is about 150, what it's saying is that it's going to take you approximately 150 years to get half of the value that originally started. And that's the only one that shows that it's that. Okay? It's going to take 150 years for that change, that half, to occur. And so I want you to see if you can kind of use that logic to find your answer to this question. Notice the only difference is sort of in terms of units here, that it's not, the power is not representing a change by years. The time is the change in days for this. So when you look at this function right here, the fact that you see this fraction in the power of the exponential growth or decay, now the base is a 2, so it's exponential growth, it's doubling, and it's doubling every how many units of time? It doubles every 6 units, right? That's the denominator. So it grows every 6 days, it's going to double, which is your answer choice B. All right. The last topic that I want to talk about here is just the next type of problem here, isolating quantities. Again, this is very consistent. This has been around since 2016 when they changed the format. These have been in pretty much every SAT, so you can expect to see something like this. And these are almost always equations from, like actual equations from math or science formulas. And then they ask you to find a specific variable. And so I want you just to try that here on this problem. I'll go through it and then we'll end for the day. So once again, if you scan those answer choices, you see everything is k equals. That should tell you right away. You're going to take whatever formula they give you and you're going to solve it for k. And the other thing that you should notice when you scan the answer choices is there's grouping symbols that stay in there. And so that should tell you you probably don't need to distribute your number. So you don't need to distribute the 9/5 to solve for k. Just treat everything. You're going to treat some things with grouped symbols. Okay, so if I took this equation right here and I want to solve it for k, the first thing I'm going to do is I'm going to isolate the part of that equation that has the k in it. So I'm going to subtract 32 from both sides. Okay, and here's the part where rather than distribute by 9/5, what I can do is I can just multiply both sides of this equation by the reciprocal 5/9. That's going to get rid of my fraction here. The 5 and the 9 cancel. And on the left side, it just leaves it as 5/9 times that binomial, f minus 32. And so to isolate k completely, I'm going to add 273 to both sides. And so there is my k value is all alone. And so I look for this form right here. I get 5/9 times the f minus 32, all plus 273. And so that would be my solution.